Hi everyone, this is Carolyn and I just wanted to welcome you back. We are going to be talking about my second video here is still on the normal curve. Video number 1 talked to us about that empirical rule, that 68, that 95, that 99.7, when we are 1 or 2 or 3 standard deviations away from the mean. However, a lot of times in the world, in life, in the real world, we are not exactly 1, 2, or 3 standard deviations from the mean. We're 2.6 or 2.8 or whatever standard deviations away. And in order for us to deal with those situations, those questions, we had to come up with a curve that we could all use and basically make a connection between the real world and something we can handle. And mathematicians or statisticians came up with a standard normal curve. The standard normal curve is still a normal curve, but we made it nice and simple. We put the mean at 0, and we made a standard deviation equal to 1. We wanted nice numbers. So if we looked at our standard normal, okay, here's our normal curve. It's that bell curve. Kind of putting my scale down there. The mean, again, reminding you, is in the middle. So that means we're at 0. So our mean, our median, and mode is at 0, which is kind of like our number line. We like to put 0 in the middle of our number lines. Our standard deviation being 1 allows me to have those magic numbers, those numbers that coordinated with the 68, the 95, and that 99.7, to be 1, 2, and 3. So between -1 and 1, we are going to have roughly 68%. Between -2 and 2, we're going to have roughly 95%. And roughly 99.7 between the -3 and 3. What we have found is that this curve is so important that we wanted every value possibly in this spectrum. So what has been created and what we have for you guys is a table with those values. I'm going to show you the picture first so we can kind of get a feel for what this looks like. The table will give us, in decimal form, you'll notice there's little decimals all over in here, from the middle, that 0, to some value outside. And you'll notice that z is on this value. It is to the positive side. We'll talk about the negative in just a few minutes. Not a few minutes, few seconds, but we're going to deal with the first one first. So we are able to do just about any value to 2 decimals. So I'm just going to jump right in and just dealing with the standard normal. So all of these examples in this video will be in the standard normal. In the standard normal. I want to find the percent between 0 and 1.28. Okay, I like to draw pictures because they help me. So I'm going to draw little pictures. You'll see lots of little curves. Standard normal is at 0. 1.28 in reference to 0 is on this side because that's the way we like to go positive. And we're going between, so I'm going to kind of shade in that little area for us. To use the table, what we will do is the first 2 digits, that 1.2, is going to be found going down this side. So you'll see that it's 0.0, 0.1, 0.2. So we're going to come to that 1.2. Then my 8 is where I'll get that other digit. So we're going to go across. So this would be like 1.20, 1.21, 1.22, 23, 24. And we want 1.28. So that's 0.3997. So from the table, we see that it's 0.3997. So I'll put that from table, which as a percentage is 39.97%. Okay. Let's do some more. So let's now find the percent between a negative 1.86 and 0. Okay, again, I'm going to draw a picture. So draw a little picture. Here's my little curve. Well, that one's a little fatter. That's all right. It's for picture purposes anyway, just for our help. A negative is going to be on this side, 0.86. And we want to go from here to here. All right, you will notice there are no negatives anywhere on this picture. So what we will have to remember is that this curve is nice and symmetric. So I want you to think of the mirror image of this on this side. So basically flip it over and it will look exactly the same. So this point here would come up to that 1.86. So we will actually look up 1.86 on the table. And when I do that, make sure you guys can see this, 1.86, make sure I get over there, whoops, up here, 0.64686, so 0.4686, 0.4686. This table is found on our Blackboard page in the assignments tab for Unit 3, so make sure you look it up, open it up while you're working or print it out, whatever works best for you. But that is where it is located. If you go out and do research on normal curve, like just YouTube or Google normal curve, there are other tables that are out there. Be careful because it could be a little bit confusing because things will be done slightly different than what we do. If you can understand those curves and those tables better, I'm okay with that. You'll get the same results. It's just different than what I'm showing you and different from what's in our supplement. Okay, let's finish this one off. One thing to remember is that percentages are always positive. So it's not like we can have a negative 46.86% of the population. No, 46.86% of the population or percent of whatever we're talking about will be in this area. All right, let's do another one. Let's find the percent between a negative 2.03 and 1.97. Okay, so I'm going to look up, draw my little picture. Whoops. 0 is in the middle. A negative 2.03 is on this side. 1.97 is on this side. I probably should have moved it in a little bit. That's all right. This is just to help me visualize. Okay. What we're going to do is use our table, and we will look up both of those values. So we're going to look up 2.03, and we're going to look up 1.97. All right, when I do that, 2.03 is 0.4788, and 1.97 is 0.4756. Okay, so I'd go down to 2.0 over to the 3, 1.9 over to the 7, and I get those values. Now the piece to remember is that the table always gives you from the point to the center. So kind of looking at these guys here in two separate pieces. So this 0.4788 is right here, 4788. This 4756 is right here, 0.4756. So if I want to go from here all the way to there, we will add these two numbers together. So 14, carry a 1, 14, carry 1, 14, 15, carry a 1, 9. Which as a percent is 95.44%. Okay. One thing I want to show you is that our empirical numbers are kind of here. So we're going to actually look at, we're going to find the percent between -1 and 1. All right, so I'm going to draw my picture. There's 1, there's -1. Since those are my standard deviation, what we should see is from the empirical rule, which we did in video 1, this is roughly 68%. Okay, so what I'm going to do is I'm going to check our tables. So I'm going to look up 1 on the table. Okay, the first thing I need to realize is that the number 1 is 1.00. So finding my 1.00, so that's 1.0, and then it's the first column, which is 0.3413. Whoops, that didn't come through very well. 3.413, which means from 0 to 1, right here, 0.3413, which also means on this side, even though it doesn't look like it, 3413. So to go from here to here, I would add these guys together, so 0.6826, or 68.26%. Roughly 68%. All right. Let's do a couple more so we can see every situation. So let's find the percent between a -2.75, and again we're still in that standard normal, and a -0.84. So I'm going to draw a little picture, complete with sound effects. All right, so there's my 0 in the middle. A -2.75 is down here somewhere. Maybe down farther, may not be down that far, but again, pictures for just a little bit of help. -0.84 is on this side, and we are going between. So I'm kind of shading that picture for me. We're going to look up both those values. So I'm going to look up the 2.75 because I don't have negatives, and my 0.84. 2.75 is 4970. 8.84 is 0.2995. So I'm looking those up on the table. Okay. Now I'm going to go back to my picture and remember what the table gives me. The table gives me from that point to the center. So from 2.75 to the center is 0.4970. From my point to the center, it's 0.2995. I want this region right here. So what I'm going to do is take the big whole part and get rid of this guy. So I'm going to subtract. And when I subtract using my calculator, I get 0.1975 or 19.75%. Okay. 2 more examples and we will have covered every situation. This could also be on this side. So if we had 2 on the same side, same idea. So think of finding those values on the table, looking them up, then going back to the picture to help you decide what to do with them. Do I add them? Do I subtract them? The other situation is when we get little tails. So here we go. So we're going to find the percent that is larger than 1.63. So I'm going to draw my little picture again. There's my 0. 0 is the center. It's the mean of the standard normal. 1.63 is here. We want to go larger, so that means bigger. That means this direction. So we are going to look up 1.63 on the table. That gives me 0.4484. All right, what am I supposed to do with that number? Well, 0.4484 is from the center to that point. So here's my 0.4484. It's not what I want. The thing to remember, the trick on this one is to remember, if I went from 0 all the way up, 0 is in the middle. So it kind of divides it into two equal pieces. Half down here, half up here. 1/2 is 50%, or 0.5. So to find this tail, I like to call it a tail because it kind of reminds me of my puppy, I'm going to take the 50% and get rid of this piece here. So I'm going to take my 50% and we're going to subtract. So again, subtract. And if I'm going to do this by hand, I got to remember those zeros and remember to borrow, but thank goodness for calculators. I subtract and I get 0.0516 or 5.16%. Okay, so 50% minus the piece, and then we'll subtract. Last example for this video. We're going to find the percent smaller than 2.07. Okay, here's 0. I always like to mark the middle so that I know where this guy is. Okay, so I make sure my picture is pretty accurate. So I can kind of know, do I get the hump? Where on the side am I? And so forth. So 2.07 is on this side. So there's my 2.707. And I want to go smaller. So smaller means this way. So that's smaller. So again, I'm going to look up that 2.07. And if I look that up, I get the number 0.4808. Okay. But that tells me from the center, from 0 to that point. So here's 0.4808. We need a little bit more than that. We need to go from here still all the way down. So to remember, this is the center, breaks it up into two pieces. This is half. Half is 50%, or 0.5. So I need to take this guy and bring in this guy with him. So that means I will take those two and I will add them together this time. And that's 0.9808, or 98.08%. Hopefully these videos are helping you understand this material a little bit better. Please, if you are having questions, contact me. Let me know how things go. Let me know if it's helping. If these are great, please let me know that so I keep them. But if you have questions, also ask, because that's the only way I know. I can't read your mind through the internet. So thanks a lot. See you in the next video.